Chapter 13, we're going to start off talking about the electromagnetic spectrum. So first of all, when we use the word light, in everyday terms, light, you think about something that you see. So this is electromagnetic radiation capable of stimulating the retina of the eye. So visible light is just part of the electromagnetic spectrum. So light is a form of energy. It does not need a medium to travel through, which means it can travel through the vacuum of space. So if we go back to our analogy about the moon, saying how, like, if the moon explodes, we wouldn't be able to hear it, we'd be able to see it, because the light would be able to travel through the vacuum of space. Visible light travels the same as every other electromagnetic wave, 3.0 times 10 to the 8 meters per second. And we use the lowercase letter c, little c, to represent visible light. Nothing can go faster than the speed of light. And again, this is just a very small part of the electromagnetic spectrum. So let's look at the electromagnetic spectrum. Now, one of the things that I forgot to put here, so I want you to add it to the notes, is on this chart. Now, for me personally, when I see things in a chart like this, it helps me to remember it. And one of the things that you're going to have to know for your quiz is you're going to have to know the order of the electromagnetic spectrum. Now, this is the order. So this is the part. Now, here, this, as far as the wavelength is concerned, this is the longest, and this goes to the shortest. Now, when we think about the equation we learned in the last chapter, V is equal to F lambda, in this chapter, for electromagnetic waves, it's going to be C is equal to F lambda. So C is always going to be the same, 3.0 times 10 to the 8 meters per second. So we see that the wavelength and the frequency are going to change depending upon what part of the electromagnetic spectrum it is. So radio waves have the longest wavelength, and cosmic has the shortest. So this is from longest to shortest. So let's talk about the parts and the uses. So radio waves, what are they used for? They're used for radio broadcasting, radar, and television. Infrared, heat lamps and baking. Visible light, this is the part that we can see. It's used for lighting, lasers, photography. Ultraviolet is used in fluorescent lamps, suntan lamps, killing germs. X-rays are used in medical examinations, like when you go to the dentist get an X-ray, for treating disease and inspecting metals. Gamma rays are used for treating cancer, because those are stronger than X-rays. And then cosmic rays are used in atomic research. So I'm going to talk a little bit more in detail as we go through these. So all electromagnetic waves, these are all electromagnetic waves. They're transverse waves that can travel through the vacuum of space. Again, they don't need a medium to travel through. So radio waves have the longest wavelength, but they have the shortest frequency. Okay? And again, here we have the opposite of that. So radio waves, they have the longest wavelength, and then there's different parts of radio waves. So one type of radio wave, which we've already demonstrated when we did a lab earlier in this year, is radar. So radar is an acronym. So when the police officers came and we held the radar gun, when you're holding that radar gun, it's actually shooting radio waves, and the radio waves bounce off the object. And we looked at that when we did that lab. So radar stands for radio detecting and ranging. So the first part, the RA, stands for radio because it uses radio waves. Okay? So we know that they're used by law enforcement agencies because we already use them. Now microwaves are also part of radio waves. Microwaves are the highest frequency radio waves. So microwaves are used for communication, and we know that they're used for cooking. Now, when we talk about radio waves, there's two different types of radio waves that are used in broadcasting. There's AM radio waves, and AM is also an acronym. AM stands for amplitude modulation. So we know the amplitude is the high or low part of a wave, right? So here, the amplitude is changing. FM stands for frequency modulation. So that means the frequency of the waves is changing. The next we have infrared. So again, these are electromagnetic waves, and these warm you. So when you go out in the sun and you can see the light, let's say you're seeing the sunshine, the part that makes you feel warm is the infrared waves. The next part of the electromagnetic spectrum is visible light. So this is the part that we can see. And if I take visible light and I break it up into its different wavelengths, I'm actually going to see different colors. So what I see is the different colors of the rainbow, Roy G. Biv. So I'll do a demonstration later and show you the visible light going through a prism, and we'll see the different wavelengths. So within visible light, we have the different colors, and the way you learned to remember it, Roy G. Biv, and red has the longest wavelength and violet has the shortest. So again, when you're remembering the different colors, you can remember this has the longest wavelength and this one has the shortest. Ultraviolet, these can cause chemical changes in your skin. These produce vitamin D. This is important. So they have done studies in places where people are not getting enough ultraviolet rays. So there's a fine line between you don't want to go out in the sun and get skin cancer, but then you also need this chemical change to take place in your body to produce vitamin D. So some people take supplements, but sometimes it's not enough. So like up north now, like they're supposed to get a big snowstorm today, when people don't go outside and don't get that chemical change in their skin, it has both physical and chemical, it affects them physically and mentally. So they've done studies in places in high latitudes like Alaska and other places like in like Norway and stuff like that, where there's extremes. Like in the winter there's hardly any daylight, and when there's hardly any daylight they see that people get severely depressed. Also, people in the Northeast here get depressed when they're inside. They don't go outside. There's not sunlight. They see that women, instead of getting their period every month, they might get it every 2 weeks. So it changes their body physically by not getting enough sunlight. So sunlight is important, and your body needs this chemical change to take place. So, again, sometimes if people don't take supplements, supplements aren't the same as things occurring naturally in your body. So it's important to get a little bit of ultraviolet rays. Now, they also use ultraviolet rays to kill germs. They use it in hospitals to sterilize equipment. Maybe you've seen something like that in your dentist's office with some tools. Someplace you might have seen it maybe I don't see it so much in hair salons, but in barber shops. You might see the barber might put some of his tools underneath an ultraviolet light to kill the germs. You know, the clippers and stuff like that to sterilize them. X-rays, these electromagnetic waves are shorter than ultraviolet. They have great penetrating power. So you all know that X-rays are used by dentists. But you probably don't realize X-rays have other uses, that when they build a building and they have like steel beams, a steel beam is made by pouring molten metals into a mold. When something cools, does it cool evenly? The outside cools first, and then the inside cools last. So what happens is, and this maybe happened to you when you made a cake. Did you ever make a cake, and you take the cake out, and it looks good, and then you cut it open, there's big, like, air bubbles inside? And maybe if you studied earth science or geology, you see, like, even with a geode, how the crystals form on the inside, because it cools the slowest, and the outside cools different. So what happens is when they build beams for buildings, there can be a hidden defect within the beam. So what they do is they actually x-ray beams to see if there's any type of little bubbles or imperfections inside the beam. Because what if I built a 40-story office building and there was a beam on the bottom and it had a defect in it, and it might collapse and the structural integrity of the building might be compromised? Is that a good thing? No. So what happens is that another place that they use the x-rays is for airplane engines. The turbines in an engine, the thing that looks like a fan blade that spins around in an airplane engine, okay, those are fatter and then they get skinnier. And those can also fail. So would you want an airplane to be up at 30,000 feet and for some reason the blade fails, and then it could cause the whole engine, the metal, to fail? So they also x-ray airplane turbine blades to make sure there's no little hidden defect in it. So that's another application of x-rays, is x-raying metals to check for the structural integrity of things that are molded. Gamma rays have the shortest wavelength, and these are what they use so when someone has radiation treatment, they're not using x-rays, they're using gamma because they're a lot stronger. The only thing with this is, besides treating healthy cells, it also treats, the cancer cells. It treats healthy cells. So the one equation we have here is, it's just like V is equal to F lambda, except this is C is equal to F lambda because all electromagnetic waves travel at the same speed, 3.0 times 10 to the 8 meters per second.